All right, everyone, thank you for coming out. We're going to hear from Davey about profiling in PHP, and some of the sponsors are Automatic and MySQL, MongoDB, among others. So if you see them out in the hall, please go talk to them. They're great. They help us put this on every year. So take it away.
We are? Yeah, we're good. Okay. Morning. It is just 10 o'clock. I suppose it's noon at home, but it doesn't count anymore. I've been here 2 days. All right, so does anybody get the quote or the reference in the talk title? Spaceball. Who's getting that? Who's seen Spaceballs? All right. So in this talk, we are going to go to black. So I'm Davey Shafik. I am the author of this one great book and 2 others. And actually, that's my publisher for the good book here. It's been updated, that's why it says good. PHP is an awesome book, but it's now 2 or 3 years old, so it's starting to get a little dated. There's a lot of non-coding stuff in here, because like Git and all that sort of stuff, so it's still relevant, but I read this one. I'm a contributor to Zen Frameworks 1 and 2, PHP documentation and PHP internals. I'm the original creator of FAR, PHP Archive, which was actually PHP and somebody smarter wrote in C. And I'm at Shafik on Twitter. That is the best way to reach me. I work at Akamai. We run about 1/3 of the internet. We have some really cool APIs and really cool technology even outside of our CDN that we're known for. Check out our APIs at developer.akamai.com. I was mentioning prompt, but I feel like Ed's kind of done this. I'm the co-organizer of prompt, and it is .org. But yeah, check out prompt. All right, so let's get into this talk. Jeff Atwood said, hardware is cheap, programmers are expensive. And I absolutely agree with this rule. But you still have to be respectful to your hardware. And yes, I'm quoting myself on a slide. So there are a number of common causes for slowdowns. Number 1 is going to be your data store. It doesn't matter if you're running Postgres or MySQL or Oracle or your web scale or you're running Mongo. It does not matter. Your data store is almost always going to be your biggest cause of bottlenecks. Other external resources, APIs, file systems, network sockets, external processes, these all kind of come next. Then you have bad code. I'd like to say the only great code is code that never has to run. And you can have code that runs once and it's cached. That's pretty good code. If it never runs, it's great. You should probably delete it as well. So, right? So really, we don't have anything that's great code. I like to do what's called the performance loop. This is how I diagnose problems and improve the performance of my applications. And what that looks like is this. So we benchmark, look at the results, we profile, look at the results, make some changes, and then we benchmark again. And by going through this cycle, we can iterative, whatever, we can loop through and make changes in small incremental steps. And make sure that they're always positive, because they're not. So for those who are not familiar with profiling, and specifically the difference between benchmarking and profiling, because they can kind of get a little mixed up, profiling will record the relative speed, the memory usage, and the number of calls, as well as a call graph of the application. The problem is that the act of profiling, just like quantum physics, impacts the performance profile of the code you are profiling. So observing changes to what's going on. So we're always looking at relative numbers. Even still, they can lie. Benchmarking tests your actual speed. It's actually what your users will see, and it's how you verify that the decisions you've made based on the profiling have actually made the changes you think they have. And that's how you avoid making negative changes based on the impact that profiling has negatively on your application, accidentally. When should you profile your code? The number 1 mistake that I see is not asking this question first. Do I even have a problem? Assuming that you have a problem is the worst thing you can do. Perimeter optimization is a complete waste of time. And unless you have a goal, how can you know when you're fast enough? And just stop. I know that we kind kind of think that it should always be faster, but there comes a point where you're starting to not get the return for the time you're spending, and buying hardware is just cheaper at that point, and it's a better way to go. So what you need to do is determine what your desired performance needs to be. So for example, you're going to say we want 100 concurrent users on a server getting sub 10 millisecond response times. Right? That's a goal, that's a bar that you can now reach, and then you're going to benchmark on that hardware, and then you can tell, do I have a problem? Am I reaching that goal? And if I'm not, how far am I away from it? How big is my problem? How much work do I have to do? Right? These are questions you have to ask before you can start profiling. There are several types of those, two types of profilers, and there's several kind of implementations. There are what I call active profilers. I don't know if these are real names, but this is what makes sense to me. So an active profiler is something you're only going to use in development. It's enabled and activated by the developer. So it's a sort of switch you're going to turn on when you want to do it. It gathers way more information than the other type of profilers, but it has a hugely negative impact on performance. What that means is you cannot run it in production. And the number one we see is Xdebug. And Xdebug is amazing. As a debugger, it's not great as a profiler unless you're doing those one-off type things. And it's integrated like PHP Storm. There's also, I think the Debugger has a profiler as well. They now have Zgrade, which is a passive profiler. So passive, am I right on that, Adam?
Yep.
Okay. Passive profilers are minimal impact on performance. That's the goal. While gathering enough information to make decisions about changing your code for performance, and they can be used in production. So, for example, you turn it on in production and you say, I want 1% of our requests to go through the profiler, and let's look at things over time. So the one that I use started off as Facebook's XH Prop. It got forked to uProfiler and then abandoned. And then a company called Tideways actually came along. They built a product around the XH Prop, and they have a fork that they're maintaining. So I'm actually looking at Tideways these days. Obviously, I gave a talk yesterday on PHP 7, so you kind of asked me not to mention what the state of it is after these come out. There is at least, I think there's 3 forks actively working on PHP support from the main XH Prop repo. But I consider that project unmaintained at this point, the original XH Prop from Facebook. They're not giving it any love. uProfiler also seems abandoned. I think people are just too busy. Tideways, however, is a company, and they're building their company around this product. So they are actively working. There's a pull request in progress. Apparently, there's a pull request and they work against it to solve the problem of having it work correctly in PHP 7. So it's coming. So if you're not there yet, I guess install it and you get 50% free, and then you can work from there in a few months when they got it going. So as well as XH Prof, there's another project that I use alongside it, which is XH GUI. And what it is a front end that will take the data that XH Prof kicks out. It will store it for you. There's a hook into your application code that will store that data and then give you a UI for actually looking at and reviewing the data. It uses Mongo for its storage. Its biggest dependency on it. You don't have to run it in production. You can actually kind of do it offline. I'll go into that. But, yeah, XH GUI is by a gentleman called Paul Reinheimer. He runs Wonderproxy. If you saw Gemma's talk yesterday, she works there. It's a pretty cool project. So if you're installing this, as I said, I'm going to Tideways. Like I redid all of this stuff when I was preparing for the talk, and Tideways is the one that I decided to go with. It's really, I say it's really simple. I might be mistaken in that because I do it all the time. But you just clone the repository, and there'll be a link to this slide a little bit later. You CD into it, you run PHP-IOS, which sets it up to be compiled in a shared module for PHP. You run configure, make, and potentially sudo make install. Just add extension equals tideways.so, and because we're not using the Tideways product, it is an open source fork that is still compatible with XH Prop, and we don't want to pay them. We just turn off this auto prepend library, and we're going to pull in our own auto prepend that will do profiling for us. Now that comes with XHGUI. This is also really simple to install. You clone it, you CD into it, and then there's a little install script which basically just does a close and install. It checks the permissions of some of the folders and stuff like that, and that's it. It is a web app, so you do need to set up a web server, or, well, maybe. Essentially, there's the document root, which is just /web root inside of the XHGUI project. You just set it up like any other simple PHP app. So if you want to do it on Nginx or Apache, you can. Or you can use the CLI server, so just -s 08080 is the port, -t web root will set the web root to document root to web root, and that's it. And that's all you do. That's what I do. XHGUI has fairly extensive configuration, and it does some pretty cool things. It resides in config.default.php, which you could modify and it gets loaded anyways, or you can specify config.php and it will be kind of appended to this and override it. So for example, by default, it uses MongoDB on localhost with no password, using 27017, I think is the default port. You can change that in the database options. You can also make it save to file. And this is what I was talking about with offline handling of the results. Rather than log to Mongo, and rather than having like a Mongo cluster handling all this data, you can just save it to file, and then you can load it into XHGUI into Mongo using the import script that's part of XHGUI. I don't like this, but it's available to you. So to use XHProf, really you're using XHGUI. You need to make sure that you turn on, or rather you include this external /header.php. It's a very small script that includes the code that comes with XHGUI that sort of sets up the profiler, sets the options for it, sets the storage up for it, and actually stores it at the end of your request. On the command line, you just do -d, which is how you set any PHP INI flag with the PHP command line. These slides will be available, and it'll be way easier to read, just let you know. So -d auto prepend file equals XHGUI external header.php, and the rest of the standard arguments -s to your application. So in my case, public is my web root, and public/index.php is my router, and all the requests will go through that. So if you've never used the CLI server, it's really cool. It doesn't support HTTP yet, we'll get there. For Nginx, you just set a fast CGI parameter for PHP value auto prepend file equals, and Apache is a PHP value auto prepend file after the file. These are all pretty simple. You do, as I mentioned, you don't have to profile every single request. If you're Facebook, they're probably profiling 1/10% of requests because they get so many, right? They just need to get samplings. The way that you do that is there's a config option called profiler.enable, and you give it a callback, and if that returns true, then it will turn the profiler on. So in this case, we're returning ran 0 to 100 equals 42. Will give us approximately 1 in 100 results, depending on how good your random seed generator is. Here we have 0 to 10 equals 4, will give us 1 in 10, right? If you return true, it will always be on. And in dev, that's what you're going to do. That got me yesterday when I was testing. It's like, why is it It also has the ability to perform URL simplification. This is the default. By default, every single URL that it logs, they just replace all equals and then numbers with nothing. What this allows you to do is compare URLs that are similar, probably have the same code path, without caring what the actual data going into it was, although that is a bit cool to see that. I use this one. What this does is it replaces all numbers with XXX, or a set of continuous numbers with XXX, and then it parses the query string and replaces all query string values with XXX. And what that means is I don't really care what they are, I just want to make sure that they are all there, and they're the same ones for the requests that I'm preparing. So, to actually profile and run your code, pretty simple. So we're going to look, I mean, all of this, XHProf really is a very minimal extension. You're not really going to be interacting with it directly. Everything you're going to do is through XHGUI. There's a number of terms that you're going to have to come to grips with to understand current scope. So if you call a function, it will give you all of the information just for what happens inside that function and not all the subcalls that it makes. And then inclusive is that function and all the subcalls. Sometimes you care, sometimes you don't. I usually care. There's a whole bunch of other things. There's the call count, which is how many times a function or method was called. There is the wall time. Now you notice all of these have inclusive. Sometimes it's shown in the UI, sometimes it's not. It's implicitly there. Wall time is what it took, right? This is what you perceive it to be. There's CPU usage or CPU time, which is how long the CPU actually spent running the code. That's really going to matter when you're on a machine that has lots of stuff going on. If CPU time is way different from wall time, it probably meant they just couldn't get access to the CPU and maybe need more processors, not better code. Okay. Memory usage, so that's what's currently being used by the function. It's kind of an average for the whole thing. If you've ever get memory usage in PHP, the difference between memory usage and peak memory usage is the same as that function. So peak memory usage will just be the peak memory usage. You'll notice these sort of two-character WT, CPU, MU, PMU. These come up a lot because these are really long terms otherwise. You also have the exclusive variants of those, except for call count. So inclusive all time CPU, time memory usage, and peak memory usage. So we're going to try to do a demo. I am hoping that the demo gods respond with me, and we shall see how that goes. Now, if it doesn't work live, I have like screenshots, and we'll walk through it, but hopefully it will work. I have a Docker container, I'm going to restart it. So what this demo is when I first looked at writing stuff about profilers, I decided that a good project to look at as an example would be WordPress. Who's running WordPress? All right, 25% of the internet runs WordPress. And I figured if I could get a 1% gain in the software that runs 25% of the internet, just the amount of power saved would be quite low. I thought that was kind of a noble goal. And I thought it was pretty unrealistic. But as it happened, I got, I think, 21%, depending on your situation. So let's look at that. I want to walk you through what that process was like. This is against WordPress 3.9. One of the patches that I wrote is in 4.1. The other one we're still debating on because it changes things. But yeah, we'll take a look at what that looks like. And I want to walk you through this process of how you might go about diagnosing and fixing a performance issue. For those, does anyone use Docker? So for those who don't know, it allows me to spin up the same environment exactly. Because I'm on a Mac, it's actually running the VM, so I start that up. So let's do that. So that way. Everybody can see from here up. Environment that I built, it does use CLI server, and I can just switch between running WordPress or running its HTTP on the same instance, and those are logged into MongoDB that's sitting there also. Now, normally, profiling inside of a VM, benchmarking inside of a VM is not something you should do. VMs are just way too slow. But because we're looking at relatively speaking inside that machine as that's running. I'm just going to run a little script on WordPress. So it's running. So there's WordPress, right? This is the standard WordPress install. I use WPCLI to install it. It is the base WordPress page. I'm going to refresh that just a couple of times. If you look at the date, for some reason that's the only way you can see that happening. So I've now done that 5 times. That represents 5 users coming to the site. Now, what we see later, more time would be better, but obviously I'm going to live demo, so we'll see how that goes. I'm just impressed I got this far, so let's see. So now I'm going to run XHP. There we go. I refresh this magically. It becomes XHP. I'm going to make this bigger because this is hard. People read that? In the back there? Okay, cool. So there's kind of a lot of information going on here. Let me make this smaller just for one reason. There. There's a huge menu across the top that got minimized, so I want you to see that. Recent being recent runs. Longest wall time, it will bring back from the database ordered by wall time, longest first. Most CPU, most memory, this is pretty obvious. You can also do custom reading where you just do straight Mongo queries, which is quite nice. We have watch functions, which we'll get into, and then we have the waterfall, which I really don't use, but it's sort of a representation of the data as a whole. So, what you're looking at here is a whole bunch of information. You have the method, the URL that was requested, in this case it was / was the home page. The time that it happened, wall time, CPU time, memory usage, and peak memory usage. Now, looking at this, there's one thing that stands out to me immediately, and I can see it because there's 5 requests. Does anyone want to tell me what it is? It's what? Well, I hit it 5 times, so that's right. So this is from newest to oldest, and the very first one took 770 picoseconds, so over half a second, and then the next one was like 100 picoseconds, or 100,000 picoseconds. Anyone tell me why?
Caching?
Up cache, right? So there are things like that in mind. It's fine for you to be running the op cache, and you probably want to because you want it in production. But just bear in mind, it is going to skew some of your results, and so make sure that you're checking after they get cached. So there's actually, these tables are really cool, every single one. You can sort of click and sort on all these links. And then there's 3 links here. Actually, there's 2. This, the method, and the time link to the same place, and then the tiny little link in the middle is the / link somewhere else. Which is great. So, actually, I'm going to bring this off of my iPad so I can remember what the heck I was going to show you. Let's try it. Because I was going to write like slide notes, and I'm like, wait, I'm not going to be able to see my slides. So that's not going to help me at all. That is not what I asked for. Yeah, there's no one else to see. Sorry, 1 second. I got caught in the key. I'm sorry. All right, yeah. So if you go ahead and click on the URL, you can see the data for that particular run. I'm going to make this smaller so you can see it all. So what we're seeing here, you probably can't quite tell because we don't have any data over time, but we will later. What you're seeing here is a graph of CPU time over time. So all of the requests for this particular URL, with that function applied, it simplifies it. In this case, obviously, it's nothing. It will give us a date time say. So you can now look at, say you deploy a change, you can look at the hour before and the hour after. What changed in production with your performance? Was it negative or positive? Same thing for memory usage. Down here we have every single run that then go into an individual run, which you get to through clicking on the time or the method. We see this. There's 3 bits of important information on the left-hand side. There's sort of the information about when the request happened, wall time, CPU time, sort of an overview. Then we get the get data, which is really cool. So if you see one request that is slow and kind of out of the way slow, like it's an obvious sort of data point that doesn't fit the rest of your profiles for this particular URL, then you can maybe start digging into the data. What is going on with that data set that maybe is less efficient to query? Maybe they have some weird thing going on. Maybe they've added one too many posts to their forum contributions, and that's why it's slow, right? We also have things like the server, and I believe it will also list the posts and such as well, if those are there. Then we have what I think are probably the most useful parts of this information. We have 2 graphs. This is the self wall time, and it will tell you the top 6 functions and how long they took. And then you have what are the memory columns. And basically, it is the same as this list down here listed out. So in this case, the slowest thing is call user function, which is really weird when you consider that I said data stores should be the slowest thing. But we'll take a look at that. And then below that, it's kind of dropped down because the screen is too small. You can actually see everything that got called. Now, as I mentioned, you can sort on every column, and what I like to do generally is to click on that twice, the call count, and see what got called the most. And in this case, it's apply filters. So if you don't know WordPress, it has this sort of callback system where you register what are called filters, and then they get called against different things that are happening in the system. And it was called 1,917 times, which potentially seems like a lot. Self-wall time, it comes up right here, 3rd. It's after database queries, which I kind of expect. I'm still a little weirded out by the volume on the right, that should actually be there. But it's still, it seems a little bit anomalous to me because it is not being called a lot and it's taking a lot of time. So let's dig into that a little bit. There's a whole bunch more information on here. So all of the self stuff, that is the exclusive. And then you have all the inclusive stuff. When I'm looking at this, I do generally go by inclusive. I do kind of want to know where the change starts. That's really important to me. So if we go ahead and click on any function in here, we'll see details about that. And what we see is the actual function itself is basically the same data that we just saw. So we have a frame of reference. And then we see all of the things that called it, those are the parent functions, and then all of the things, there's a lot, all of the things that it called. There's not so many of those. Generally, I don't care so much about parents. There is an awful lot of parents, so maybe you got it in 2 places. Maybe we're calling some object to do something that we're just kind of calling because it might apply to this context. And I know some of us might be defensively code doing that. Oh, it won't harm anything from this in here except performance. We don't care about that right now. We just want to get stuff done. We know what's up great. Whereas children, you can start to see what on earth is going on to take so much time inside that function. So, call user func array is taking the most time. And if you actually go look at apply filters, it is basically calling callback. So that is what the majority of the function does. You'll notice here at 1, at 2, that's when you have recursive calls. So at 1 is the first recursive call, at 2 is the second recursive call. Right? Right. So from here, I go switch. Okay, let's see what's going on. sequence, it's going to call all three of those no matter what, just 3 lines of code that run every single time the function is called. Which is, we know it's also called several times. So let's take a look at the translate function. This is the translate function. So this takes the text in a domain, which defaults to the full. As I said, there's probably 3 functions that get called no matter what. Get translations for domain, translations translate, which if we look is no up translations translate. You can infer that as the same function. It's totally going to call. And then if we scroll down just a little more, we have the apply filters. So from the information in the profiling, I actually was able to guess what this function was going to do. Now that makes me awesome, but I looked at it beforehand, so. But what does, it's called no-up translate. What does it do? Anyone want to take a guess at what no-up translate does? It's nothing, right? And it's the default, which you can just use for English. And that's why I said this only applies in certain cases. So if you're running English, it will instantiate a class called no-up translate, called translate on it, that literally just returns the string that gets passed into it. Nothing else happens. And this was added in like WordPress 2. Right? It's been there for a while. So I thought, well, why am I instantiating this class? Why am I calling this extra method when I don't need to? I still need to apply filters because all of the other callbacks need to happen on it. But the translations that are not actually happening don't need to happen. So what I'm going to do here is if a bulk, sorry for spacing if you like. Still works, which is a great first result. I don't have any caching on the front end yet. It is a base install. I'm not running macros caching. So yeah, WordPress is still working. This is a good result. That's the first thing we want to check. We're going to refresh it a couple times. Anyone want to tell me why? I'll cache. Right? Want to compare about a certain number of requests, WordPress will call a WP cron, which is how they do all their cron stuff, which is kind of also terrible at the same time. It will easy, pretty slow. So now we can see we've got a bunch more requests in here. And if we look at our wall time, it has dropped from the hundreds down to the 90s. That's not bad. That's what we want to happen. How do we confirm that it was the change that we made and nothing else? Or how do we even confirm that our change actually did what we think it did? So we go into, first of all, let's see here. I mentioned trends over time. So this generally operates on a much larger time scale than we're doing today. There is thankfully over here a search. started off really high, that's our first uncached hit. We went down when we first cached, and then you can see it kind of grew a little bit, and then it dropped dramatically, which is what we expected when we contained. If we want to ensure that, again, that the change we made had the effect, we know it had the effect we wanted to make it faster, but is it for the reasons that we think it is, which is that it's not calling that node, right? Let's confirm that. So we do that by going into one of these runs, and there's an option up here called compare this run. And what we can do is we can pick any of the previous runs to compare against. So let's look at one of the sort of the normal ones, which is 157 or so. Compare. Now, there's up here it says base and new. I actually want to flip that. So it's the base actually where I started, which is the older one. I always start with the new one. If I click reverse here, then base goes to the original request. We can then see that the number of function calls was 27,573. The older one, yes, the base is the older. That's right. 27,000 is the older one. 26,000 is the newer one. We've decreased the number of function calls by 1,232. Does anyone want to tell me what that is? The number of function calls divided by 3 compared to 2. So we got rid of 2 function calls if it was default, right? So that lines up. Let's take a look at the call counts. So get transitions for domain and all transitions has decreased by 660 calls. So this confirms exactly what we expected it to do, and that's great. Awesome. There is still one thing you're going to have to do at this point. You still need to benchmark because the profiler is still throwing numbers out loud. So I'm not going to do that now because that's not the point of this talk. We're all about profiling. To make sure that everything that we've done out, this is correct, you're going to definitely want to okay, yep, okay. So there was something I kind of glossed over on the previous. So up here, alongside so inside of the individual run, at the top, you see this watch functions. This is a really cool feature that when you use it, is cool. Otherwise, it's just what functions are is the ability for you to find regexes that will match against function names and pull them up to the top. So, for example, if I go into add a watch function and I do MySQL, my question mark, star, save, and then maybe I add star. Because WordPress has different adapters, using any of those. And I save that. And I go back to where I was. You see now it's pulled all of the MySQL stuff to the top. Right? It is still pretty sure it's still in this whole set as well. So you can kind of see it in context. But say, for example, you wanted to do profiling against a specific class, you would put that into your watch function and pull it up to the top to that. So this is a really cool feature. There is also up here the view call graph button. Let's see if this will work. This is a full call graph of the request. So basically, this is the main function, which is the script itself, and we can go through here and see everything that was called and the basic WordPress. So this is something special. I love WordPress, but it does the job and it's fantastic. What's cool is that every single one of these elements, obviously it's too much, too small to read. If you hover over it, it will tell you what it is, and then you can actually click on use it whole, and it will take you back to the function details page. So you can see some of these start with what has the most function calls and the most wall time, or CPU time. Those are the things that are probably going to look this out. I generally don't care about memory, but if that's the problem you're running into, then obviously you're going to look at that. Dig in, see what's calling it, what it is calling, start looking through like that, and then change code, check again. So that particular change for English gives you, I believe, either a 9 or 11% performance increase, which is pretty cool, and that's the one that got it to forward. There is another one. The other thing that jumped out when you look at the light filters itself, which is called a whole bunch of times. So as I mentioned, I did the change with the switch that we'll call it numerous times. Actually, what I wanted to do in PHP 5.4, 5.5 and above, you actually don't need closure on the array at all. And whatever 5.6, you can use splats even better. But they like to do 5 patterns. So that patch didn't get in. But the way that they loop through the filters is also really weird. They have an extra assignment in their iterations that they don't need. So check that out as well. That's the other patch that's either 9 or 11%. So at this point, it looks like we have, say, my watch is past 10 minutes. So does anybody have any questions? Do I have any personalized?
Question.
Yes.
So when you realize you have a slowness issue with your application, at what point do you decide I'm going to look for ways to cache versus I'm going to look for actual slowdowns in my code itself and trying to do?
So as I mentioned, the only good code is code that doesn't have to run. I'm always in favor of caching. That's always going to be, I want to say always a good absolute, but it's generally going to be a good performance increase regardless of how fast it goes. So I would always start with caching. Once you find that you have problems. Things like this, if you are caching aggressively and very well, the times you're going to run into these kind of performance bottlenecks is when your cache gets blown away. Maybe you start a new server and you have the cache empty where everyone's trying to hit it, it has to be cached in. You obviously want that to be as fast as possible to get your cache warmed up and get people hitting it fast. So there definitely is the need to make your code run fast, even if you have cache. You want to make that process of building your cache as quickly as possible. So don't mistake what I'm saying for just cache and forget all of this. This stuff is super important. Any other questions? Has anybody looked at this stuff before? Do you have any comments on the way they did? Do you have to do anything differently? That's good enough. All right, so with that said, I'm now really self-conscious about this. That's the join min link, but Ed said they changed, so maybe it's not. They're linked to on the site. Whatever. As I mentioned, I found it. I'm at Shafik on Twitter. That is the best way to reach me. If you are an email person, shafik@akamai.com. If you go to daveyshafik.com/slides, then you will find these slides up. Tideways is available at github.com/tideways, and then the profile extension. And XHGUI is under github.com/perfecttools. Go check these out. These tools are really cool. I really like this idea of passive profiling. I love this idea of having it in production, being able to sample actual production results over time. For me, that over time aspect is incredible. Even if you don't check it regularly, maybe you do a monthly recheck and you've done 12 deploys during that time, you can see which ones impacted it, because you know, we deployed on Wednesday at 4 p.m. and oh look, performance got or increased, right? You can see these kind of things, you can make correlations, and that for me is a huge part of the power in this. It's not just this active process of going through, looking at, like I did, like hit it and do a look at it. It's actually that over time information. So yeah, if there are no more questions, thank you very much.